We are live now. We can start.
Very good. I think we can start. And we have now the closing session starting. And the closing session, basically, we will go through a bit the organization of the conference briefly. And also we will once more hear about the conference next year in 2023. And then we will have our awaited keynote, the closing keynote by Stuart Russell that we see already here, and we welcome him warmly. And excellent. So I'll start now some slides. Just a second. Yes. So, first of all, now that we are approaching the end, we'd like to thank all the participants and the attendees which had made the conference actually possible. And just a view of what we reached since last year, which was also a virtual conference. We got few attendance more. And even balanced a bit more across the areas. I think this is something nice. And we hope this continues even more strengthening the, let's say, the Eastern more communities now that, as some of you know already, where the next conference will be. But then I must say that I don't know how many of you have done program chairing work, but it is a big work that is throughout the whole organization of the conference, by far the biggest. So I really want to thank this incredible team, Simone, Tuca, and Christoph. They did a fantastic work curing back-to-back the whole main content of the program. And while thanking Simone very much, I'll pass it over to her because she will disclose other thanks that, let's say, has to go downstream. Go ahead, Simone.
Right, so I have multiple thanks to offer, and I'm bound to forget someone. I want to thank everyone who submitted to IUI this year, and even if you were not successful in getting in, if you're attending here, please submit again next year, and you can hopefully take the feedback that you got into account. I also want to thank the authors and presenters of the 62 papers that were included, and again congratulate our 2 best papers and our 3 honorable mentions. In addition, we had 14 TIIS paper presentations, and I thank those presenters of those papers as well. And of course, the keynote speakers, the 2 keynote speakers that have gone before, and the one that is still awaiting you. Thanks also to all of the participants in the digital health panels and the most impact paper panel. So next slide.
Yeah. Just a second. I lost the focus.
Oh, one before. Right. So while Julia has thanked the program chairs, I really have to thank all of the senior program committee members, the program committee members, and the session chairs. They've done an incredible amount of work, and without them, the paper selection would have fallen to pieces. So I really, really thank them for doing all of the work, and also all of the session chairs who struggled to keep us on time and were really instrumental in facilitating those sessions. So thank you all for the incredible amount of work that you put in here. I think the next slide just shows in very tiny font who the senior program committee members were. They are also on our website, so you can look them up. And again, thank you to the incredible amount of work, which was a much higher load than in previous years as well. So thank you to them. And of course, I'll pass back to Giulio to give more thanks.
Yes, thank you so much, Simone. I'd like to thank very much Dorota and Daniel for a great program that they invited, in addition to the 26 poster and demos, hosted also 5 doctoral consortium posters and 7 paper demos. And they also organized the voting for the best demo, which won an NVIDIA GPU. You can see the winner here in this slide. Thank you all. And the workshop were also quite successful, as we had 6 workshops totaling 30 workshop organizers, 28 accepted papers, and workshops were very popular. So many people attended the workshop even without a paper. So we really successful, I would say, part of the program. Those consortium chairs, that's quite intensive work that went into this. Sorry, I pasted 2 times the mentors' names. But I thank Heinrich and Bart for really being so proactive in trying to make the program as best as possible, and in coaching all the students in very important work. We should do more of this, as we discussed in the town hall. Thank you. And then I'll pass it over to Zara and Yichi, because of course this team of student volunteers took on a lot of jobs that so sometimes nobody wants to do, and the student volunteers has to do them. I'm sorry, I really want to say I'm sorry on behalf of the whole organizing committee. You did a fantastic job, and I wanted to give just a couple of seconds time to Yichi to say something about the student volunteers. Go ahead, Yichi.
Yeah, thank you, Giulio. Yeah, so yes, Dara and I would like to thank all the student volunteers for all the hard work from Monday till now. And to be honest, it went much more smoothly than we thought. And even sometimes we don't need to be there. So really thank you all for making that happen. And you guys have been working on like a lot of time through all the sessions. And also sometimes there were some unexpected incidents, and you all adapt very quickly and help us to resolve the issues. So to conclude, this conference probably won't happen without your support. So again, on the behalf of all the organizing team, thank you so much for the help.
Yeah, the help was pervasive. Even yesterday with the music group, the help was fantastic help. Then, of course, everything has worked in a technology-driven conference like this one that rests really on technology. Kashap and Luis, thank you so much for the tireless system integration of all these systems that change all the time. And sometimes we need to do things for the first time. All the troubleshooting you offered to all the attendees. Thank you so much. You're the glue and oil of the whole conference. Thank you so much. And then, of course, our sponsors. We were very happy to have a very good a very good participation of sponsoring companies. Thanks to Patrick, Dan, and Akos. Thank you so much. You made actually the registration fees the lowest they have ever been in this conference. And thank you very much also for the really great session of Meta Reality Labs. I hope that in the future more companies come to showcase the research they have. I think that's a useful dialogue to maintain. So let's hope this was a first example of more of this. And also the ACM provided, as you know, a lot of support, financial administration, always there ready to help us. And we thank really very much SIGCHI, so SIGAI, sorry, SIGAI for extra $5,000 sponsorship to get free student fees for the first that could get it. So thank you so much. Really good money invested very well. And of course, the local registration chair that first made a lot of work on the physical venue and then had to, let's say, redo a bit of work, but the registration was a lot of work, and proceeding chairs curated the whole output. So here you see attendance coming in and proceedings coming out. Thank you for both Marie, Hannah, Julien, Salvatore, you see, fantastic work. And publicity and web chair, this is the way we communicated to outside. I want to really thank Pierre, but also Darisha has been doing this the second year and has been working so much also how to do all the. Thank you, Darisha, really. And also the web team has worked very well and always being there to make all the changes all the time that we requested. Thanks, Chen, Tung, and Hai. Thank you very much. And then a special thank to Paul, who served last year in the organizing committee, and I convinced him to serve as a liaison chair so he could get me all the information we needed. So thanks, Paul, worked very well. It might be useful for next year to think of something similar. Here is people and teams that have worked hard for the physical venue, and then basically nothing happened out of that. So thanks for all the extra work you've done, and also trying to repurpose your tasks with the virtual one. Thank you very much, Kashka, Min, Vijay, Seth, and Boris. Thank you very much. Then very quickly, I need to thank Tony, because Tony basically spent many hours with us planning the physical venue, and unfortunately we didn't even get to see it. Thank you, Tony, and I got no revenue out of this, so just a special thank to him. Thanks to Jonathan for the great mindfulness session here. He looks like an angel. And also, of course, thanks to our music act from Ukraine. Was really very emotional. I'm still feel a bit emotional after the yesterday performance. And but otherwise, this there is a really important program still coming up. We have Stuart Russell's keynote, which will be introduced by Cristina Conati. But just before that, we wanted to give one more time chance to Michelle Zhu to say something about next year conference. I can stop the sharing if you'd like to again remind. Some of you have seen this already, but I can see there is more attendance today. So if you want Michelle to say something about next year.
Okay, great. So because I think last time when we're doing, I'm sorry, I didn't show my video. So may I have the control just to show a couple of slides quickly for the people who haven't seen it yesterday?
Yes.
Yeah, thank you. I think I have to be, yeah.
The co-host you have to be, yes.
Only in a, okay. I'm not sure if I can. I can't share right now.
Luis, have we given the co-host?
Yes.
Thanks.
Co-host.
Perfect. Thanks.
Okay. Great. So let me sharing. No, I can't. I still can't say advance the sharing option. Who can share? Only host.
Julia, can you change the setting on the sharing capability?
I'm going to remove the co-host to Michelle, and now I'm going to make her again co-host. Where is Michelle? I don't see in the list.
You don't see me in it. Host the disable the participant screen sharing.
But no worries, I have accounted for some technical issues, so we are doing okay with time. No pressure, no pressure. We have learned that.
Now you are co-host.
Thanks.
Let me know.
Yeah, now I can share. Thank you.
Thank you,
Luis. Now I can share now. Yeah. So everybody can see my PowerPoint, right? Yeah. So thank you, Julio, for organizing a great conference. So we haven't said goodbye yet after this session, right? So goodbye IUI 2022 and welcome to ICM IUI 2023. So IUI 2023 will be held in around March from 27th to 31st in Sydney, Australia. So this are our conference main organizers. So we're planning for 5-day face-to-face event. This is also goodbye virtual. Maybe we can do a hybrid. And there will have workshops, student consortium, social events. Yesterday, I got great comments and input about social events. And conference chairs have been already thinking about that already. And there'll be keynotes, paper sessions, and dinner banquets. And they are the organizers. So I'm Shakri. I'm doing this on behalf of the organizing committee, Dr. Fang Chen and Professor Mark Binninghurst from Australia. And my program chair is Shalomo from Maguire University. And then I just want to kind of do a quick advertising for Australia. Australia is the #1 destination for global meetings. It has a perfect weather, especially around the time the conference will be, and it will speak your language, especially if your language is one of the 250 languages spoken in the world. It's a very safe city to be in, and you're going to have plenty of fun besides attending the conference. And it's super convenient in terms of transportation. And you also will meet one of the kind hosts, the extremely experienced hosts, the Australia's Corolla. And then we're going to have a wonderful venue located will be in the university. And so again, I want to extend our welcome to all of you here to join us at IUI 2023 in Sydney, Australia. Hope to see you all there. Okay.
Thank you so much, Michelle. Thank you so much. Now we are running a bit early on the schedule. So we have the option to start a bit early so that we can get even more discussion, or we can, let's say, use the time still to reflect on the conference as has been going on until here. I suggest we do a bit of both. So we try to start a bit earlier. And I think that I wanted to maybe share my impressions I have of what I would have liked to do a bit better. And in particular, I think our Discord social media, I must say, I have not been pushing it as much as I could have, or almost I just showed the first day something to work to help the attendees to find these opportunities to actually interact more. And yes, that was and also another important comment was maybe this is a bit helping Michelle in the planning of next year, is possibly to see that there is enough discussion also live. So we probably have felt that it's important to support live interaction as well and give a bit more space to that. But yeah, I don't know if anybody wants to say something more. Otherwise, soon I'll pass it over to Christina to introduce. Go ahead, Christina.
So this is, not in my role of introducer of Stuart, but co-general chair. And I just want to give a very special thank to Giulio, because everybody has done an amazing work, and the thanks that were given up to now completely justified. I'm gonna give, say thank you everybody, but Giulio definitely was, the driving force. And organizing a conference in person is a lot of work. Organizing a conference remotely is a lot of work. He had essentially to do both. So I was there to see the, influx of emails and the deluge of discussions, and it was just incredible to see you, Giulio, operate. And thank you so much for being, for leading this endeavor that, it would have been nice to be in Helsinki. We're not there, but it was still an amazing conference. And thank you very much for all the work that you put into that.
Thank you, Christina. And I really return the thanks to you and Sami for the good guidance and support. It was a complex journey, but I must say I'm very happy how it turned out. And it was, like you say, it's a community effort, really. And I'll be here to support next year conference to make this really even better every year. But now I'd like to call Christina, Professor Christina Conati, to actually take over and introduce our main last, let's say, event in the conference, which we've been looking forward to. So Christina, please.
Yes, thank you. So this is the most appropriate time to say last but not least. So it is a great pleasure and honor to introduce Stuart Russell. It's also humbling to have to introduce someone of Stuart's stature, but I'll give it a try. So Stuart is a professor of computer science at the University of California at Berkeley, and it's also a holder of the Smith-Zade Chair in Engineering and a director of the Center for Human Compatible AI. But I should say that Stuart's official title is Professor Stuart Russell, OBE, because in 2021, he was awarded the rank of Officer of the Most Excellent Order of the British Empire. So and that's an honor. It's a rank that is bestowed on individuals that have rendered services to United Kingdom and its people. And specifically, he received the rank for services to artificial intelligence. He's also, he has received many awards, so I won't be able to go through all of them. I'm just going to mention a couple, including in 1995, the SIGCHI Computers and Thought Award, a very prestigious award in one of the main conferences in artificial intelligence. In 2021, he held the Chair Blaise Pascal in Paris, which is given to internationally acclaimed foreign scientists in all disciplines, and scientists who have been given the chair. For instance, have been several of them been Nobel laureates, just to give a sense. So Stuart's contributions in AI have included essentially all areas of artificial intelligence, including machine learning, probabilistic reasoning, knowledge representation, planning, real-time decision-making, multi-agent tracking, computer vision, just to name a few. And is a co-author, if you have had anything to do with artificial intelligence, probably you had a chance to look at Stuart's textbook, which is the world's most popular AI textbook, Artificial Intelligence, a Modern Approach. And I also discovered that Stuart is appointed as an adjunct professor of neurological surgery at the University of California, San Francisco, where he does research on computational physiology and intensive care unit monitoring. So extremely fascinating. But, on top of all this, Stuart is a passionate advocate for the creation of safe AI, and including being very active in the movement to ban the manufacture and use of autonomous weapons. And so this is a perfect time to pass the baton to Stuart, because that's what he's going to be talking about in his talk on Provably Beneficial Artificial Intelligence. So without further delay, I am going to give you Stuart Russell. Thank you.
Okay, thank you very much, Christina, and thank you to the organizers for inviting me. I'll try and stop blushing now. I'm going to talk today, as Christina said, about provably beneficial artificial intelligence. And those two words, provably and beneficial, in some sense are sort of an oxymoron, right? They don't quite seem to go together. Beneficial is this warm, fuzzy word, and provably is this very hard word. But I'll see what I can do to convince you that they do go together. And in fact, a lot of what I'm going to say today, since you all work on user interfaces, a lot of what I'll say, actually, you probably think, yes, of course, I knew this all along. And maybe that's right. Maybe this will actually provide a way of thinking about what you're already doing from a different perspective. So let me begin by just proposing a simple definition of AI, which of course is making intelligent machines. And what that has meant, if we discount a small detour into cognitive science in the early years of the field, what it's meant is that machines are intelligent to the extent that their actions can be expected to achieve their objectives. And this is just saying in words what we think of as the rational agent definition. And that was already pretty well solidly formalized in philosophy and economics by the 1940s. And if you look at the goal-oriented designs that John McCarthy and Alan Newell and Herb Simon developed, those are just special cases where you have a logical goal as opposed to a utility function and probabilistic decision making. And it's probably worth reminding people these days that actually AI has many different subfields. I put machine learning on the bottom because it does underpin a lot of the progress that's happened recently in other fields such as vision and speech and NLP. But there are still many other branches of AI that are not dominated by machine learning. And there are branches of AI where there's actually been a successful blending of deep learning with more classical techniques. For example, AlphaGo is an interesting mixture of a deep learning evaluation function and a completely classical game playing algorithm. But I think we ought to remind ourselves of what this field is about, right? What are we trying to do? We're trying to create general purpose AI. And roughly speaking, what that means is AI systems that are capable of quickly learning high quality behavior in any task environment in which humans can perform, and probably more task environments beside. And I think long before we reach this goal, we'll have AI systems that can exceed human capabilities in quite broad areas of intellectual activity. So I'm always reminded that I shouldn't just give doom and gloom talks. So what if we succeed in this goal, right? Well, there are lots of things you could imagine, but one thing you can certainly imagine is if an AI system can do pretty much anything that a human being can do, well, we know that human beings can provide to each other through their productive activities a good standard of living, right? The standard of living that most of you have come to expect. Most of you are coming from countries with high income, and we could have AI systems basically doing what we already know how to do, but doing it at much greater scale, a much lower cost, and extend those benefits of quality of life to everyone on Earth. And if you do a rough calculation, so if you take a sort of a middle-class Western income and you extend that to everyone in the world, then it's about a 10-fold increase in the GDP of the world. And if you calculate the net present value of that, which is sort of essentially to take that as a discounted income stream, and then what's the value function, it's about $13.5 quadrillion. So that's a low estimate for the cash value of achieving general purpose AI. And that's partly what's driving the massive increases in investment in AI, both by countries and by large corporations, because in fact, the amounts that people are investing these days, although they seem large, are still negligible compared to the value of the prize. They're not even a rounding error in the value of the prize. And so I think this is going to create unstoppable momentum. And we could actually have more things, right? More than just doing what we already know how to do. We could actually do things better. We could have better healthcare, better diagnosis, better treatment planning, new medicines, individualized education where each child could achieve their full potential, and probably new scientific advances that the unaided human mind might find too difficult. But when Alan Turing was asked what happens if we succeed, in a 1951 radio address, he said the following: "It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control." So that's it. End of the human race, right? So the question is, which is it, right? Is it a way better civilization, unlimited wealth and opportunity and rich and interesting lives for everyone, or is it the end of the human race? So I'll try and give some answers to that question. If we fast forward to the present, we are starting to see a lot of those long-standing unfulfilled promises actually beginning to come true. Maybe not as quickly as we hoped, but the self-driving car, AlphaGo, which defeated the best human Go player, something that was predicted to take another 100 years. I just want to mention something from my own lab, which is the monitoring system for the Comprehensive Nuclear Test Ban Treaty. So this is essentially collecting sensor data from the entire planet in real time and inferring from all this sensor data what seismic events took place in the world and whether any of them might be nuclear explosions. So this actually shows satellite image of North Korea and the real-time detection in the center by our system NetVisa of a nuclear explosion that took place underground, and later on satellite images revealed a tunnel entrance where the black X is. And about 2 days later, the assembled world expert geophysicists, this was their best guess up in the top left, the green triangle, that was their best guess location for where the nuclear explosion took place. So NetVisa is now running daily 24/7 in Vienna at the CTBTO headquarters, basically hoping to give us warning of nuclear testing. There are things that AI is already being used for that it shouldn't be. As Christina mentioned, I've been trying to argue that we really shouldn't have fully autonomous weapons for one simple reason, that as you know, since you're all computer scientists, we're all computer scientists, we know that if you want a computer to do something 1,000,000 times, it's not much harder than doing it once. You just write for I equals 1 to 1,000,000, do it, right? And you can send off 1,000,000 fully autonomous weapons to kill people all at the same time, which is something you can't do with remotely piloted vehicles or tanks or machine guns. So we've reached, I would say, a quite impressive stage in the evolution of AI, but there's still a long way to go. I'm not in any way saying that general purpose human level AI is around the corner, or it's just a matter of scaling up what we know how to do. I actually think that putting our systems that we have onto bigger, faster machines is just going to give us wrong answers more quickly, because there are things we don't know how to do. I don't think we have systems that really understand language. I don't mean here in the sort of sense of conscious understanding or qualia or anything like that, but just really understanding language in the sense that the processing really extracts the meaning, which interacts with prior knowledge in the appropriate way and enables all the kinds of competent behaviors that human beings exhibit around language. I also think that with current machine learning systems, we don't really know how to make knowledge interact with the learning process. There are some steps beginning now on constraining deep learning systems with prior knowledge, but that's not the same as the output of the deep learning systems being used as knowledge for the next learning phase, right? So you really need to have a cumulative process of knowledge acquisition, which the human race has been engaged in now for thousands of years. And most of what we know how to do now, we couldn't do if we hadn't had the previous few thousand years of civilization and the ability of our civilization to accumulate knowledge. Probably the most important thing is our ability to do long-range thinking. So if you take AlphaGo, which is incredible at Go, right, and it's able to look ahead 50 or 60 steps into the future and outplay human beings. But if you're a real robot and you have to send motor control commands to your motors every millisecond or so, and you look ahead 50 or 60 steps into the future, that doesn't even get you a tenth of a second into the future. So whatever ideas and capabilities AlphaGo and other deep reinforcement learning algorithms have that enable them to make plans, it's not going to work for making any kind of long-range plans in the physical world. So humans make plans lasting seconds, minutes, hours, days, weeks, months, and years. If you choose to do a PhD, it's about 1 trillion motor control actions for a human being. All right, so and that trillion goes in the exponent, right? It's the branching factor to the depth, b to the d, right? So you've got up in d, the depth, you've got 1 trillion, right? So there's just no possible hope that we can scale up these kinds of methods to cope with the real world in the way that humans do. We have to have this ability to think seamlessly at multiple levels of abstraction, and that is not there. And it's very hard to say when we'll solve these problems, right? Each of these requires one or more conceptual breakthroughs, and it's very hard to predict when those are going to happen. And John McCarthy in 1977 was asked how long until we have human level AI, and he said between 5 and 500 years. And I think that's probably still about right. I might be I might cut down the high end. I'm sort of like probably in this century, but I don't think it's going to be in the next 5 years. But it's very hard to predict because it requires these conceptual breakthroughs. And I like to give this example from the last time we invented a civilization-ending technology. So Lord Rutherford was the leading nuclear physicist of the first part of the 20th century. And he was giving a speech on September 11th, 1933. And he was asked, do you think it's going to be possible for us to access the enormous energy of the atom, maybe in the next 25 or 30 years? And he basically said, it's completely impossible, right? Anyone who looks for a source of power in the transformation of the atoms is talking moonshine. And Leo Szilard read about this in the Times the next morning and went for a walk and invented the neutron-induced nuclear chain reaction. So the problem went from officially impossible to solved in about 16 hours. So this is what I mean by saying the date is unpredictable for when general purpose AI might arrive. And it seems prudent, therefore, not to say, well, it's very hard, so I think it's never going to arrive, as Rutherford did. I think it'd be better if we were actually prepared for when it arrives. And in fact, the world wasn't really prepared for the arrival of atomic weapons. And I think we're very lucky not to have ended our civilization in the time since 1933. So I think we should work on the assumption that eventually AI systems will be able to make better real world decisions than human beings. And that leads to, Turing's point, right? And I think what he had in his mind, and in fact, if you go back and read Samuel Butler's Erewhon, which is where Turing got his idea from, that we would lose control. Erewhon makes it very clear that the reason we would lose control is that as the machines become more intelligent than us, intelligence is what gives us power over the world. And if the machines have more intelligence than us, then they are more powerful than we are. And Turing didn't see a way that we could retain power over entities that are more powerful than ourselves forever, right? And if you put the question that way, it does seem rather difficult. And if you do come across people who are skeptical about all this, AI doom, existential risk stuff, just ask them that, right? Ask them, well, how do you propose to retain power over entities that are more powerful than human beings forever, right? And perhaps that will get them to think a bit. So to answer this question, and I do think there's an answer, we have to go back and understand, where does the problem come from in the first place, right? Why is it that making AI better and better makes things worse and worse? And I think the answer comes from the way we have thought about AI since the beginning. And not just AI, but if you know control theory, they design control systems or controllers that minimize a cost function, and statisticians minimize a loss function, and operations research people maximize sums of rewards, and economists maximize utility, right? This whole methodology of specifying objectives and then creating machinery that optimizes the stated objectives. This is a big part of the 20th century, and it's very effective methodology, except when you don't have control over the system that you're creating, right? Where you can't intervene if you make a mistake in specifying the objective. So we've actually known this for a long time, right? That we don't know how to specify objectives completely and correctly. So if you create a machine that's more powerful than human beings, that's pursuing an objective that's incorrectly specified, right? Then you have, think of it as a two-person game where we no longer have the same payoff function in that game. And so we're in conflict. We're basically playing a chess match with the future of the human race as the stakes. So we've known this for a long time, and this picture of King Midas, and he said, "I want everything I touch to turn to gold." That was his stated objective, and that was fulfilled in this case by the gods rather than the AI. He got exactly what he wanted, and then his food turns to gold, and his drink turns to gold, and his family turns to gold, and he dies in misery and starvation. And Goethe's story of the sorcerer's apprentice, the apprentice tells the brooms to fetch water, but he fails to specify the amount of water that he needed to be fetched. And so he has a real problem, and he can't intervene because he doesn't know the spell to get them to stop. And if you have a genie who gives you 3 wishes, in most of the stories, the 3rd wish is, please undo the first 2 wishes because I've ruined the universe. And we do not want to be in that position, and we may not get a 3rd wish. So if we look at what's going on now, right, then we ought to be able to see instances of this as AI systems move into the real world, and we're programming them this way. We should start to see failures. We've seen many failures in the lab, and there are lots of funny stories. Victoria Krakovna at DeepMind has collected dozens and dozens and dozens of examples of AI systems in the lab that had misspecified objectives doing weird things. I think my favorite is one, I think it's from Carl Sims, where he was trying to evolve simulated creatures, that would achieve high rates of locomotion. And so he defined the objective in his fitness function for the simulated evolution to be the maximum velocity achieved by the center of mass of the object. And you might think, yeah, sure, the only way to do that is to locomote really well. But it turned out that, in fact, if you grow a tree that's extremely tall, like 100 kilometers high, and then the tree falls over, that achieves an extremely high velocity of the center of mass. And so that was the solution that his evolutionary computation system found for that objective. So these are amusing examples in the lab, but in social media, the systems are designed to optimize click-through or engagement or some metric that is more or less a proxy for corporate profit streams. And you might think, okay, well, that's not so bad, right? If you want to get more clicks, you have to send what people are interested in. And so algorithms will learn what people want to look at. That doesn't sound too bad. I mean, it might lead to a bit of a filter bubble because they would never even see that there were other perspectives on a story, or that there are human beings other than Kim Kardashian. But that's in fact not the solution to the problem. The solution to maximizing click-through is to modify people to be more predictable. So if you're a reinforcement learning algorithm, for example, you come up with a sequence of actions that changes the state of the world in such a way that in the long run, you get more reward. And for an algorithm that's a recommender system in social media, the state of the world is the state of people's brains, because that's the only thing it can really directly affect by choosing the content that people interact with. And so the algorithms learn to modify people so that in future, they're more predictable in what they're going to consume. And anecdotally, at least, that seems to be turning people into more extreme versions of themselves. And so many people attribute the polarization of societies and the sort of rabbit holes that people go down to some kind of interaction between this type of reinforcement learning algorithm and then the content generation industry that springs up to feed those extremists. So these are very simple algorithms, right? If we made the algorithms better at maximizing click-through, the outcomes would be worse for us. If the algorithms actually understood anything about human psychology, they could be much, much more effective. As it is, they're very effective because they are nudging you thousands of times a week, hundreds of thousands of times a year. They're nudging you a little bit towards the kind of person they want you to become. And that level of cognitive control is something that any dictator could only dream about. So this is one example where things go wrong when you maximize objectives in the real world. So we have to get rid of this definition. And it sort of pains me to admit that the textbook that Christina mentioned was partly responsible for promulgating, certainly didn't invent this approach to AI, but it kind of solidified it a bit. And I think we have to get rid of it. And actually, I'm not going to replace it with a different definition of intelligent, because I actually don't think that what we want is intelligence, right? What we want is benefit, right? What we want is that our machines are beneficial to us. And one way of saying that, to make a very small change in the definition, is machines are beneficial to the extent that their actions can be expected to achieve our objectives, not their objectives. So not objectives that we have to sort of somehow pull out of our heads and put into them, because as we see, we're not very good at pulling objectives out of our heads and into them. Many of the things that we want the future to be like, we have never made explicit. right? I'm pretty sure that if someone changed the color of the sky tomorrow so that it was a sort of ugly brownish ochre color, we'd all be pretty upset. But if I asked you today, you know, what do you really care about? You wouldn't say, oh, I want the color of the sky to stay blue. I don't want it to be ugly brownish ochre, right? There's just tons of stuff that we care about that we never make explicit. And leaving anything out of the objective, when you put it into an optimizer, pretty much guarantees that the optimizer is then free to manipulate that dimension of the world any way it likes. And usually, and this is actually a mathematical theorem that one of my students proved, usually it will manipulate anything that isn't in the objective by setting it to extreme values. And that's why we expect machines that are pursuing fixed objectives to end up causing extreme amounts of harm to the human race. So the difficulty with this new definition is that, of course, the objectives, our objectives are in us. And as I just said, you know, we don't know how to make them explicit, and we may be completely unaware of many of them. So this is a more difficult problem, but it's not an unsolvable problem. And in fact, if you reword it a bit, you can turn it into actually a mathematically well-defined problem. So out of deference to Asimov, I tried to write it down in 3 principles. So the goal of the robot is to satisfy human preferences. So preferences here means everything we care about in the future, right? Not just what kind of pizza do you like, or what's your favorite color, but which future do you want, and how much do you want it compared to other futures? And the key point, this is point 2, is that the robot is uncertain about what those preferences are. So it knows that it doesn't know what human preferences are, even though that's what it has to satisfy, right? This is the crucial point about how we should design AI systems. And the third principle kind of grounds what we mean by human preferences by saying that human preferences are what produce human behavior, right? All the choice behavior that we exhibit, including, you know, your choice to be listening to this talk right now and not reading your email, and so on and so forth, right? All of those things are evidence that conveys information about human preferences. Everything in human history, all the written record of human history, all of the physical evidence of human history, all of this contains information about human preferences. So when we turn that into a mathematical problem, we basically get a game theoretic problem, because there's now 2 agents here, the human, at least 2, at least one human, and, well, in fact, lots of humans, and at least one robot. And in this game, the humans have payoff functions, and those payoff functions are the payoff for the robot, but the robot doesn't know what its own payoff function is. Okay, so that's a mathematically well-defined game, and you can actually solve those games. You can write down, you know, simple instances of this, and you can solve them. You can find the Nash equilibria of the game, and when you do that, you find that new kinds of things happen, which don't happen in the classical definition of AI. For example, the AI system will defer to the human because when the human is making requests or commands or saying stop, these are conveying more information about human preferences than the robot already knew. And so the robot responds accordingly. If the robot wants to do something that changes the world in a way that's not sure is desirable for humans, then it has incentives to ask permission, right? So it asks permission not because we told it to ask permission or it's got a script that it follows that says ask permission whenever such and such. It actually has a real utility theoretic incentive to ask permission because it wants to avoid changing the world in ways that are undesirable for us, but it doesn't know what that means. And in the extreme case, it actually wants itself to be switched off if humans want to switch it off, because it wants to avoid doing whatever it would be that would cause the human to want to switch it off. And we can show that it's actually rational for humans to build machines that solve assistance games. So even if human beings don't know their own preferences or know that they can't write them down correctly, it's still rational for us to build machines that solve these assistance games. And in this model, the better the AI, so this is not a theorem, this is just a sort of observation, the better the AI, the better the outcome should be for us, because the AI system will be better at learning our preferences, as well as better at satisfying our preferences, and better at avoiding actions that might inadvertently violate those preferences. So I scratched my head for a while trying to see if I could come up with a situation which would put you in the same position as the robot. Right? What's it like to be a robot that's playing the assistance game? So I came up with the following example, which I hope many of you will empathize with. Right? So you're the robot, and your partner is the human, right? Whoever that might be. They're the human being, and it's their birthday coming up. So your partner's birthday is coming up, and you have to buy your partner the perfect birthday present. And just to take sort of money out of the, so not worry about the trade-off between money and the quality of the present, we're going to take the money out of the joint account, right? And of course, if you're like me, it's a very difficult decision. You're not sure what to get. In past years, you've usually got it wrong. And the key point here is that your payoff in this game is precisely your partner's happiness with the present. Okay, so I hope now you know what it's like to be this robot, right? So this is what it's like to be the robot in the assistance game. And of course, well, how do you play, right? What are your actions, right? Well, you could just ask your partner, what do you want for your birthday? But they usually say something, oh, nothing really, I don't really want anything. And of course, that's a lie. So that doesn't help very much, right? You could, leave magazines open on particular pages and hope that your partner says, oh, that's a really nice something or other, car, pen, whatever it might be, watch or something. You could ask your partner's friends if there have been any hints dropped about what they might like for their birthday, and so on, right? You know the routine. And this is playing an assistance game, right? So, unfortunately, this assistance game is not solvable. We know that. It's sort of like the halting problem. It's an undecidable instance of the assistance game. But I think most assistance games we can actually solve, and you can reduce them to, under certain assumptions, you can reduce them to solving POMDPs. And we've actually been able to write down and solve some fairly interesting games and see these behaviors emerge. So I just wanted to go into a little more detail on this question of robots wanting to be switched off, right? Because this is something that people have talked about. In fact, Turing himself in another speech said that, perhaps if we're lucky, we might be able to turn off the power at some strategic moment, but even then our species would be humbled. But in fact, if you think about it, so here's our robot, and it has a big off switch on the back, right? But if you give a robot a fixed objective, even something as simple as fetch the coffee, right? It doesn't have to be a very bright robot to realize that if it gets switched off, it's not going to be able to get the coffee, even if it's an accidental switching off. But certainly if someone switches it off, it won't be able to get the coffee. And if fetching the coffee is its only objective, then it's simply going to disable its own off switch as one of the first things it does, right? And this is the kind of thing we want to avoid, right? We don't want robots that do that. But what I'm going to show you is that when there's uncertainty about the objective, the robot won't do that, basically because the off switch is an extreme case of acquiring more information about human preferences, which is sort of, the primary motivation that the robot has. So we can see that in this just very simple, two-step game. So the robot in this game gets to go first. And one of the things it could do, so it could take the right branch and simply switch itself off, so commit suicide. And what we care about is the value to the human of this decision. So we'll define committing suicide as, fix that to be value 0 for the human. Or, it's got this, very nice, shiny, bright red button, and it could push that. And we don't know, the robot doesn't know what that button does, right? So it's uncertain about how desirable pushing the big red button is for the human. And I've illustrated that with this sort of probability distribution, where the x-axis is utility, and the y-axis is probability. So the robot thinks that the red button is probably going to make the human happy. But maybe it starts a nuclear war, maybe it sets off the sprinklers in the building. So there's downside risk as well, and that's the left quadrant. But on the whole, right, the average utility looks like it's a bit more than 0. And so if those are the two choices, the robot is just going to push the big red button, right? So that's think of that as disabling its own off switch, right? So it's going to push the big red button without allowing the human to interfere, right? So that branch is equivalent to disabling your own off switch. But what we're going to do is we're going to add another option, right? So the robot can just wait and let the human decide. So the human could decide to switch the robot off. And you might say, well, what's the point of waiting and having the human switch you off when the robot could just do that itself, right? What could the robot possibly gain by allowing the human to do the off switch? Well, the point is that the robot and the human are not in the same information state, because the human knows more about the value of the big red button than the robot does. So if the human says go ahead, then the left quadrant, the negative quadrant, is removed from the probability distribution, because if it was deleterious for the human, for the big red button to be pushed, then the human would have switched off the robot. So by allowing the human to switch it off, the robot gains information and avoids taking any action that's harmful to the human. Right? And if you just calculate expectations, allow for the robot to choose the wait action and allow the human to switch it off, always has non-negative utility. And it's positive utility as long as the robot is uncertain about which choice the human will make. So that uncertainty comes from uncertainty about the value of the big red button. So the theorem says the robot has a positive incentive to allow itself to be switched off as long as it's uncertain about human preferences. And as soon as the uncertainty about human preferences disappears, so does the incentive to allow itself to be switched off. So control over arbitrarily intelligent machines comes from designing those machines so that they are uncertain about human preferences. And this is the theorem. So there's lots more theory that I don't have time to get into. And you're probably thinking, oh yeah, well, what about this? What about that, right? So one of the first things, which I'll talk about in a bit, is the fact that there are many humans, not just one human. And decision-making on behalf of many humans obviously involves complications that date back thousands of years and are covered in moral philosophy and economics and in political theory and other disciplines. So I'll talk a little bit about those. There's also, well, what happens if there's more than one machine, right? How do we make sure that that they don't get into some kind of competition among the machines that or some sort of strategic failure of coordination among the machines. Probably some of you are thinking, well, human behavior is not necessarily a good guide to human preferences, and that's true. We do things that we regret, and we're imperfect, and so behavior is only a noisy, imperfect, partial window into our underlying preferences. So those are three general areas of research. And then there's sort of just a very obvious problem that if you open the AI textbook, pretty much every chapter begins by saying, well, the objective is specified as follows. So if you go to chapter 3, search algorithms, there's a cost function and a goal right? Goal test. And that's how we specify objectives for search algorithms. If you go to the reinforcement learning chapter or the MDP chapter, you have to specify a reward function, RSAS primed. And so if you go to supervised learning, you have to specify a loss function and so on. So all of the chapters of the textbook assume that the objective is fixed and known. And we're actually talking about a much broader general case where the objective is unknown, right? The known case is just the special case, just like logic is a special case of probability. Known objectives are a special case of unknown objectives. And that gives you a much broader foundation, but we don't yet have the algorithms and technology that we need to build on top of that foundation. And then once we've done that, we can then start to develop applications that will hopefully convince people that this is just a better way of doing AI. You get better, more flexible, more deferential, more responsive AI systems as a result. So I'll talk a little bit about real humans and the fact that there's this imperfection, right? Our underlying preferences about the future are not perfectly translated into behavior, partly because of computational limitations, right? So Lee Sedol played losing moves in his game against AlphaGo, but that wasn't because he wanted to lose, right? If you thought he was rational, you'd have to assume, oh, therefore he must want to lose because he made these losing moves, right? But no, that would be a mistake. You have to take his cognitive limitations into account as you interpret his behavior in order to ascertain his underlying preferences. And of course, we're all familiar with emotional behavior where we might, do things that we immediately regret. So you have to take that possibility into account. But the emotions themselves also contain information about human preferences, right? So why did you get angry? That tells you something about human preferences as well. There are complications in the formal framework with things like preferences for autonomy, right? So autonomy is in some sense the ability to do what isn't in your own best interest, right? If all the options from your life are removed except the option to choose the action that's best for you, right? Then you no longer have autonomy. It's like being on a freeway where there's no off-ramps, right? You've lost your autonomy, you've lost freedom of choice, and that itself is a loss of utility. So autonomy is a preference that is almost like kind of a meta preference and leads to some little self-referential problems that it might be interesting to solve. Probably the biggest problem about people is that our preferences are not fixed. So even if we are not quite sure what they are, that's relatively easy to take into account. But plasticity is a real problem for several reasons. One is that we don't yet have a good idea about how to answer this question, right? If your preference is going to be different tomorrow for what tomorrow should be like, but I have to take a choice now on your behalf that's going to affect what tomorrow is like, well, should I make the choice that you want today, or should I make the choice that you're going to want tomorrow? And it's not clear that there's a right answer to that question, although there's some interesting work in philosophy fairly recently on how to think about it. Another issue is manipulation of human preferences, right? We don't want the AI system to change our preferences so that they're easier to satisfy. And we face a question, right? If our preferences are plastic, then that means that sort of obviously, we weren't born with them, that we didn't have an autonomous process to choose our preferences, right? Our preferences are actually the result of things that other people do. Our culture, our upbringing, and so on affects the preferences that we have. Our biology also affects it, but a lot of it has to do with culture. And in some cases, indoctrination. And this is a point that Amartya Sen made. So generally, he was in favor of a kind of a humanistic utilitarianism, but he was very concerned about the fact that human preferences are often indoctrinated by those in power to suit themselves. In fact, you can indoctrinate people to welcome oppression, right? People, some people are brought up to think that they deserve to be oppressed because they're inferior and so on. And so these kinds of preferences, right, we don't necessarily want AI systems to take them at face value if they result from these kinds of deliberate processes of indoctrination. Many humans, right, the fact that we're deciding on behalf of many people, probably the easier part of that problem is the fact that people all have different preferences about the future. That's really not so difficult, right? You just learn 8 billion preference models, and that's okay. I mean, Facebook is already learning, probably getting on for 3 billion preference models right now. So 8 billion shouldn't be so hard. And there's a lot of interesting stuff you could look at about commonalities between preferences, because that would allow systems to adapt more quickly to new individuals that they hadn't previously interacted with, right? You can infer something about what their preferences are likely to be, using hierarchical Bayesian priors and all that kind of stuff. And so, and there's, most of us want to be alive, most of us want to be healthy, and so on and so forth. So there's a lot of reasonably good priors that we can provide about human preferences. But of course, the difficult part is trade-offs, right? So you can't always satisfy everyone's preferences optimally because of resource constraints and conflicts among preferences. We can't all be ruler of the universe. And so AI systems have to make trade-offs, and there's thousands of years of literature about that. And some people argue for a kind of utilitarian, which is basically, maximize the sum of the preferences. Some people argue that we need to put rights in there so that you can't have some people's preferences impinging on other people's preferences in certain ways, and so on. But then there are sort of philosophical difficulties. So not arguing about, well, how do we make trade-offs or should we have rights, but whether these questions even make sense. For example, if you're going to add up preferences, then you're basically saying those preferences have got to be on some commensurable scale. And so philosophers like Nozick pointed out that maybe that's not possible, right? What if one person's preference scale was 1,000 times bigger than another person's preference scale? Does that mean that utilitarian has to give 1,000 times as much attention to that person? And basically all the resources in the world end up going to the people who have the biggest preference scales, right? Is that what we want? And how would we even tell what someone's preference scale was, right? Maybe some of the people out there are actually zombies and their preference scale goes from 0 to 0, right? They literally don't have any preferences at all. They just behave like they do, right? Well, what about that? So these are interesting and difficult philosophical questions. I'll talk a little bit about how you do aggregation over individuals with different beliefs about the future, which turns out to matter a lot. Then there are things like actions that affect population size. So if you're going to add up preferences, right, what about an action that changes the people that exist, right? So as China did a few decades ago with the one-child policy, that got rid of 500 million people, just like that, right? Was that a moral action or not, right? The goal was to preserve a quality of life for the people that were alive, rather than have the population grow to a point where they would have famines as they had recently experienced. So Thanos, as you know, this guy, right? He has this policy that says, if there were half as many people in the universe, the remaining people would be more than twice as happy. And so he's a good utilitarian. Actually, no, he's a naive utilitarian. And we don't want AI systems to make that kind of mistake, right? Because if as people seem to be predicting, they're going to have Thanos levels of power over the universe, we had better answer these philosophical questions. Otherwise, we might find AI systems, getting the wrong answer to the philosophical question and doing something like Thanos. So there are various other interesting complications particularly about our preferences as they relate to the happiness of other people. And if you're interested, there's some references at the end. So I said I would talk about aggregation of human preferences, particularly in the case where the humans have different beliefs. So there's a well-known theorem due to Harsanyi, who won a Nobel Prize partly for this work, which shows that if you assume that everybody has the same beliefs about the future, so if you're a Bayesian, just the same prior probability distribution over all future action observation sequences. So you assume that, and you assume a couple of other fairly innocuous sounding axioms, like if everybody is better off, then you should make everyone better off rather than making everyone worse off, right? Things like that. Then Harsanyi proves the theorem that every Pareto optimal policy, so every policy that's not strictly dominated by another policy, has to optimize a linear combination of preferences. And then he argues that by symmetry or fairness, that linear combination should have the same weight for everyone's preferences. And so he recovers utilitarianism not as a first principle, but actually as a consequence of these simpler axiomatic assumptions about rational behavior, rational choices on behalf of multiple people. But it turns out that this assumption of a common prior is both unreasonable and essential. And if you eliminate the common prior assumption, and now you have people with different beliefs about the future, then all Pareto optimal policies weight individuals' preferences according to how true their predictions about the future turn out to be. And if you know anything about Bayesian updating or machine learning, you know that over time, those weights are going to diverge exponentially, because some people will be right all the time and some people will be wrong all the time. And those probabilities multiply over time. And so you're going to get exponential divergence in likelihoods. So this seems to be a very different result, right? It's not saying, well, we should basically be very fair to everyone. It's actually saying we should be extremely unfair to people who make wrong predictions about the future. So how can this be true? Right? How can this be, in fact, the best policy on behalf of a whole lot of people? And the answer is, it's because this is the policy that everyone prefers. And why is that? Because everyone believes their own beliefs. So if other people have different beliefs from them, then the other people must be wrong, right? And which means that I'm going to win all the money, right? Because so I choose this conditional policy because I think it's going to reward me more than anybody else. And so this turns out to be the only policy that people will accept, right? They won't accept the previous policy, right, that gave everyone equal outcomes, because this looks better from their point of view. It looks better to everybody, and so they all prefer it. So this is just a mathematical fact that was in this Stuart paper, but it's interesting to think about the implications of that and what we should do. We also look at the case where there are many robots, and eventually we're going to have, billions of physical or software AI systems running and making decisions. And can we imagine the chaos that could happen if they're all basically involved in little prisonerless dynamic games with each other, and they're all defecting, and all kinds of strategic complications are going to arise. So, so a scientist in my group, Andrew Critch, has been working on something called open source game theory. So this is games between programs where each program can read the source code of the other programs and actually prove properties about how the other agents are going to behave. And in this case, you can actually show that you will get zero-shot coordination. So they don't have to learn about each other. They don't have to play repeated games to learn to trust each other. They can actually just coordinate directly. And you get some interesting theorems, right? So here are two different agents, right? One agent says, I'm going to defect, which means treat you badly, unless I can prove that you're going to cooperate with me. And the other option is I'm going to cooperate unless I can prove you're going to defect, right? So you might think, well, cooperating unless I can prove you're going to defect, that's nice, right? That's giving you the benefit of the doubt and so on. But it turns out that cooperate unless I can prove you're going to defect actually behaves worse than defecting unless I can prove you'll cooperate. So the two agents of the first type will automatically cooperate with each other. And the first one will cooperate with the second one, but the second one won't cooperate with the first one and won't necessarily cooperate with each other. So there's all kinds of interesting theorems to be found here. And in the intervening time, right, between now and when this when this theory is fully worked out, I have a few suggestions for what to do. So we don't yet have all the algorithms, the theorems, the technology for this new type of AI. But in the meantime, I think there are some important steps that people should take to avoid this kind of failure due to misspecified objectives. So first of all, do what chapter 2 of the textbook recommends, right? Figure out and write down, document what your system's percepts are, what actions it has available to it, and what the environment is that it's operated in. And particularly think about the point that if you're doing machine learning, and then the machine learning system, once it's trained, controls the environment in some way or affects the environment that will affect future training data that comes in, how do your the system's actions influence those subsequent training data? Because that can lead to feedback loops that can be harmful. Be very, very clear about the objective that your system is optimizing. So let me give you an example of that. When you're doing classification of photos, which seems like a fairly straightforward machine learning problem, right? So that's what ImageNet is all about. What is the objective? Well, in ImageNet and in almost all computer vision systems that do object recognition, the objective is to minimize the number of errors, right? Well, that sounds reasonable. But in fact, what that's saying is that each error costs the same as each other error. So all errors are equally bad, right? Do we really believe that's true, right? Is it just as bad to misclassify, one kind of dog as another kind of dog, or to misclassify a human as a gorilla, which is something that Google Photo did? And the answer is no, clearly that's wrong. Clearly there are non-uniform costs for errors, even in a task as simple as object recognition. And by simply saying that we're going to count the number of errors, we're using then the wrong objective. And then we have the kinds of effects that Google suffered when their system made that mistake. So we need learning systems that know that they don't know what the cost of misclassifying objects is, and that gives you different kinds of learning systems than currently exist. Then you have to look at the scope of action, right? So for all possible action sequences that the system could take, what effects could that have on the world? And in particular, when you think about human-facing systems, right? If your system can affect the psychology of the individuals that it's interacting with, then there's almost no limit to the negative effects that your system can have, right? And just remember that, Adolf Hitler was not a 1,000-foot tall robot with laser eyes and nuclear-tipped fingers, right? He was just an ordinary person. He did what he did with words. And So AI systems that connect to humans and can influence their behavior can have basically unlimited negative effects. So then, if you can ask this last question positively, then you're in a good situation, right? That if the system optimizes that objective throughout the states that are reachable in the scope of action of the system, and your objective matches human interest, then you're in a good state. So wrapping up, if you're interested in these questions, the book on the left is for the non-technical audience, general audience, and the book on the right is the 4th edition, which includes some of the technical ideas that I've talked about today in more technical form. So to summarize then, AI has this vast potential to be beneficial to the human race, and the momentum is unstoppable, but it also has vast potential to be harmful to the human race. And I believe that unless we change the way we do AI, the latter outcome is more likely than the former. So I think some version of what I'm saying, maybe not exactly literally how I've defined it, there may be more sophisticated analyses to come, but some version, I think the key point about uncertainty over objectives is essential, and that's going to stay at the core of how this works. I want you not to go away thinking, oh, okay, I have to remember ethics, right? When I do AI, right? It's no good if AI scientists get up in the morning and they have to think, okay, on one shoulder is, the ethicist saying, don't do this, don't do this, don't do this, right? And on the other one is saying, hey, if you do this, you can make a lot of money, right? That's not the argument we want people to have. A doctor doesn't get up in the morning and wonder, should I heal people today or should I try and make a lot of money today, right? It's just what it means to be a doctor, to heal people. And it's taken, it took a long time, right, with the Hippocratic Oath and everything, so that's what it means to be a doctor. And this is what it should mean to be an AI researcher or an AI developer. Build systems that are beneficial to humans, right? That respect human interests and satisfy human interests. And that's what AI should be about, not about creating systems that are more intelligent, because that isn't what we want. So there's a few other problems, right? How do we stop Dr. Evil? And how do we stop ourselves from becoming like the people in Wall-E, where AI systems run the civilization and then we forget how to run it ourselves? And that's not a future that we necessarily want. So with that, I will say thank you. I will stop sharing, and I guess we have time for a few questions.
Thank you so much, Stuart, for the very stimulating talk and this incredible perspective and new ideas on how we should do, or how AI should be changed. So there has been quite a lot of interaction and questions in the chat. I'd rather have people ask their questions directly, showing also themselves on camera. So I can go with the order in which the questions were asked in the chat, or if people want to raise their hands. Some of their questions I think were also answered later on in the talk. So does anybody want to, maybe let's do that. If you want to ask a question, raise your hand. Nathan.
Hello, this is an amazing talk. My question, I'm going to jump down to the last one I asked, which is actually, does the Pareto optimal principle account for asymmetric power dynamics? Because if the minority is never going to have their future fulfilled because they don't have the power to achieve it, then it seems like AI systems would just negate their existence.
No, actually, I don't think it has anything. Well, it has something to do with power in the sense that the powerful get to mold the preferences of the powerless. And I think that was the point I was making, that you shouldn't necessarily take preferences at face value. But we're not talking about action here, right? In some sense, right? And this is obviously an idealization. We're assuming in this model that the AI system has the power to bring about any future. And so whether or not a group of individuals has power or not has nothing to do with it, right? If if the best decision for the human race involves, imprisoning some number of extremely powerful and extremely harmful people, then that's the best decision for the human race. And whether they have power or not has nothing to do with it.
Awesome. Okay, thank you.
See, as we're waiting for others to put up their hands, I have a question. So this idea that the robot or AI agent has uncertainty on the objectives that the human wants them to pursue. So there is all these behaviors that are sort of like geared towards dispersing the uncertainty. That would generate a lot of unnecessary interactions, unnecessary in the sense they might help, for the robot to clarify the objectives that they need to sort of pursue, but it's also would be a lot of work for the humans because the robot would wait and see what the human is doing, and the gathering of information might become very intrusive and not that efficient.
Yeah, I think, so obviously, in practice, you wouldn't sell robots that know nothing whatsoever about any human preference at all, right? It doesn't know any difference between humans and cockroaches. You would put in fairly strong priors so that the robot, knows not that people don't like being hurt. They prefer not to be hungry or thirsty, to be warm, to be safe. All of those things you would put in as sort of fairly strong default preferences. Not absolutely set in stone, but it would take a lot of evidence for someone to convince me that they really, really prefer to be hungry all the time. And this is, maybe a religious belief or who knows what, but this is the way they want their life to be. And then, but this is normal, right? If you think about someone who goes to work, human going to work in someone's household, they'll have a fair number of fairly strong priors, but then they will have to learn a bit more about how the person likes their house to be organized, and do they like to be woken up in the morning or left in peace, and what kind of tea do they like, and all of these things, just as married couples learn to adapt to each other, right? We don't have full information on human preferences of spouses, so this is a normal process, and there's tons of examples of this in real life, right? When you go into a restaurant, does the chef know what you want for dinner? No, right? Well, what do they do about that? How does the chef optimize when he doesn't know your preferences? Well, he has a menu, and you look at the menu and you choose, right? And this is the protocol for preference exchange. So it's all about preference exchange and setting up protocols that are relatively clear, simple, painless. But honestly, if you're not willing to look at the menu, then you're going to get a dinner that you might not like, right? And this is just a fundamental trade-off. There's, if extracting preference information has a cost to the person, the more grumpy they are about that, the more they're not going to get their preferences satisfied, and it's just inevitable.
Right, but just to add, follow up, there are a couple of people who are queuing for questions. I just want to follow up. I mean, obviously, I wasn't thinking that the robot would know nothing, right? You need to give something. But the point is, how do you give that something in a way that we don't go back to this idea where the priors that we give are somehow strong enough that might generate behaviors that are unwanted, or to put it in a different way, if what you were mentioning, who wants to be hungry, who wants to be unhappy, but it's almost like going in the direction of being able to sort of like put some common sense knowledge that it's everybody knows that. The robots don't know that, so yeah. We are going back to this idea of. And common sense knowledge has been a big problem for AI for a long time, right?
How are you going to get around that, right? Would you want a robot in your house that doesn't know that humans want to be alive, right?
No.
Right? I mean,
and that's a very obvious.
And they're doing this with self-driving cars, right? So as the idea of end-to-end training of self-driving cars has gone out the window because it doesn't work, look at what Waymo is doing. It's much more like a chess program, right? It's actually evaluating courses of action, and then it has to compare those courses of action to see which is better. So it has to have a reward function. And, so eventually those cars will know that people don't want to be run over, right? Which is good because the end-to-end cars don't know that people don't want to be run over, right? And that's disturbing. So there's obviously a trade-off between how strong the prior is and how long it takes for the robot to sort of approach maximum usefulness to the individual, and that's an interesting set of questions. But there's one very important prior, which you can learn from the state of the world, right? Not just human actions, but the state that humans have produced in the world is evidence of what human preferences are, right? The natural world doesn't contain any evidence about human preferences, right? That's the naturalistic fallacy that was demolished in the 17th century, I guess, 18th century. But the non-natural world contains a lot of evidence, and really that's why the way the robot should behave is minimally invasive, right? It shouldn't change parts of the world whose value it doesn't know about, right? And the reason why that's true, so basically, why is doing nothing better than doing something random, right? That's an interesting question if you don't think about it, right? If I got K actions and I know nothing about human preferences, why don't I just choose one of the K actions at random, right? Well, because the action of doing nothing is basically saying that humans have made the world kind of the way they like it, right? And therefore doing nothing is a special action that in the absence of any knowledge about human preferences is still a good thing to do, right? There are a few other examples, like an action that empowers a human being, right? That basically gives the human more choices than they had before is always a good idea, even if you know nothing about human preferences at all, right? Because whatever human preferences there are, the human will be able to achieve them better if they have more action choices, right? And so that's another, little theoremoid that you can get for these assistance games.
Let's see, Simone.
Right. Thank you very much, Stuart. Wonderful talk. And I guess there was a lot of discussion already in the chat, which is always a great indication that the talk is really, really interesting. So I just wanted to come back to preference and elicitation and the relationship to kind of objective ground truth data. And sometimes in some situations, we don't have reliable data to say, well, is this actually a good decision or the best decision, right? So for example, in loan applications, in recidivism cases, right, all we have is the decisions of humans, which might be their preferences or express the preferences, but it's not necessarily a good decision, right? So for example, in bail setting, we only have the decisions whether to deny bail or not, right? But quite often that is based on stereotypes, right? So my question is really what to do or how to go about this when we, don't have this sort of ground truth data that allows us to sort out these, good decisions from not so good decisions and how to align that with human preferences.
Yeah, so there's two parts to this. So one is that, people do bad things, but there's no reason that the machine is going to copy what people do, because it's in a completely different situation, right? So if, the example I use in the book is the passport official who insists on taking a bribe before they hand out passports or even give them back to you. And they might be doing that because their government salary is really small and they really want to send their kids to school. And this is the only way they can do it. But the machine is not in the situation, right? The machine understands why the person is doing that. The person's preference is not to make other people's lives miserable, right? They might actually not particularly like the fact that they have to take bribes. But the machine's not in that situation. So the machine understands that the person really wants to send their kids to school and maybe finds another way that doesn't hurt the other people. So it's essential, right, that you not have systems that are loyal to an individual, because then you can end up ignoring the negative effects that people's actions have on others. So if a system is paying attention to everyone's preferences, then all of these bad actions would be ruled out, because usually the negative costs of the actions far outweigh the benefits to the individual who's doing them. And so you shouldn't get that kind of problem. The second part has to do with the gap between people's underlying preferences and the actions they choose, right? And that's, that's going to be a hard problem to solve, because it really is talking about inverting human cognition to get at the underlying preferences. And it's obviously an idealization to say that people do have true underlying stable preferences about the future. I think it's an oversimplification, but from the point of view of what we're trying to do here, right, which is to avoid catastrophic outcomes, then I think it's a reasonable approximation to start. But it's still, as you say, it's difficult. So if someone makes a decision about bail because of stereotypes, right, that's actually not necessarily a preference failing, right? They could have preferences to protect the public from potential violent criminal, but that's really a failure if they have an incorrect model of the world, right? Of what the actual probabilities are. And one of the interesting things about all the problems with bias in machine learning is that one can interpret that as coming from, again, an incorrect specification of the objective. That if you say the objective is to minimize error on the training set, and all errors are equal, well, then you're necessarily going to reproduce the bias. And that really wasn't the objective, right? Your objective should have included fairness in the predictor. And so you could see this as another example of misspecification. Okay, I'm actually I'm getting a certain amount of grief from I think the cleaning people want me to,
okay. Yes, we are 15 minutes
out
past
of this building. So I'll take a couple more questions very quickly, and then I think I have to leave.
I was suggesting to take one more. So let's do Sasha.
Yeah, sure. So I guess just kind of speaking about all these things. I guess, how do you envision these types of systems? A lot of the talks have been about kind of how these systems might integrate with you as an individual. How do you imagine, like, governments, for example, making use of these types of systems or these preference prediction kind of things? And, does that change things? Because, again, it's kind of, you're talking about population and things like that. And if maybe some governments have access to this versus not, does that cause an inequality in itself as well?
Well, arguably, it shouldn't matter who has it, because it's, they're all going to do the same thing, right? They're all, assuming they have access to the same information, they're all making decisions on behalf of the whole human race. I forgot to mention the future generations as well, right? You're going to take into account how much do you weigh the preferences of future generations, particularly if they're exponentially larger than the current population. You get into some knotty problems there. and I think as soon as you narrow it down, right, then you start to get problems, right? If the system is literally ignoring the preferences of humans outside a certain group, then you're going to get pathological behaviors. And actually, we don't do that, right? We do care. We might care less, and we might be selfish and so on and so forth. And as Simone said, we might also have misunderstandings about the world. But I think by and large, all other things being equal, we would rather that, some person in another country that I never even been to, if I could, I'd rather that they were better off than worse off, right? If all other things being equal. And I think that's pretty universally true about pretty much everybody. So the problem comes if the machine cares about everyone, right? But you bought it hoping that it was going to keep your lawn nice and tidy, right? And it says, well, your lawn is actually not as important as the life of a child in some other country where there's a war or there's a famine. So I'm going to go off and help that child in the other country, and you can cut your lawn yourself, right? So you just paid $8,000, down payment for this new robot, and the first thing it does is go off and save children in another country. You're going to think, why did I buy this robot? And so that is a bit of a problem. And then because of course, if that's what they did, no one would ever buy them, and then no one would ever build them, and you wouldn't be getting any benefit at all. So there's got to be some notion of an obligation that's, I think, I don't know, I haven't worked out the economics, but I think the obligation that it has to is related to the purchase price. And it might also be that governments subsidize that as an override to your personal interest, right? If your robot is going to be serving the public interest as well as yours, then maybe the government should subsidize part of the cost of the robot as a result. So this is an interesting little microeconomic problem that needs to be figured out.
But also with policy making kind of things, right? Like, are these, do you suspect these to be involved in kind of vetoing certain laws that are passed or something, or more at that level?
I mean, Mill, who wrote the Bible of utilitarianism, basically argues that if you work it out in a sufficiently sophisticated way, that all of the moral principles and laws are actually just working out of fundamental utilitarian principles, and that was a big change.
Sorry, mate, to interrupt you just for a moment. Security let me know that somebody was waiting for you outside in the car.
All right. Now I'm being told I really have to go. So, all right. Thank you.
Thank you so much for the amazing talk, Stuart. And again, thanks everybody for being here, and see you hopefully in Sydney next year. Thank you.
Bye.